Ah, magnet, sir.
All right. Let me all right. So as we say, all I will just explain a while ago is the answer. Because how is the voltage generated in the stationary coil? The question I already tell you the answer, you know. It says here, when the handle is turned, the magnet also turns in the presence of the coil. This produces current. So all you're going to do is write the word, write the key word here. How can you get how can you get voltage, right, from a magnet? That's a question, you know. What word did I show you a while ago that you must know the meaning of? What's the term?
This term, electromagnet.
Yes, electromagnetic induction. I just write induction. That's all they're asking you for one word answer this. You going to
Or
write, so that's right, electromagnetic induction.
it's the same thing as magnetic also, though, sir.
Magnetic induction. You have to write induction. You have to use the word induction. If you write induction, you possibly will get, yeah, you will get the mark. What is induction? How is it? The process is called induction.
No, sir. I
Because
was asking if you could write magnetic. If magnetic induction would be same thing as electromagnetic induction.
yes, they'll accept it, yeah. Right. But it's just that electromagnetic is the term because it's a more it's just a more common term because they want to say that the magnetism is produced from the electricity. But that's okay. Induction would give it a mark, even if you didn't put anything before it. So it's an induction. Induction means that you introduce something. And what you introduce here? Well, the handle is turned, the permanent magnet also turned in the presence of the stationary coil. So inducing, you're introducing magnetism or magnetic force into the wire, which causes the electrons in the wire to move. And the next sentence says this produces an electric current which charges the batteries. So the whole concept we're talking about is electromagnetic induction. All right.
Yes.
All right. So let's say how it is. You get 1 mark for that, but I'm pretty sure they would want more for the other marks. Let's see what else. 5 marks for everything here. But electromagnetic induction will give you some marks. They mark what additional component is needed to be able to charge the batteries. Um, well, certainly you can use, okay, I think what they're trying to say here, the batteries use DC current, so you can use AC current to charge it. What additional component is needed to charge these batteries? All right, so then this is producing AC. When time this rotate, say magnet move. Anytime magnet is used to produce a current, it's always AC. Um, and then no, the battery is DC. So let's underline batteries and remember that this is a DC current. So they're looking for the device that can convert the AC to the DC additional component to charge the batteries. So what device converts AC to DC? Because electromagnetic induction produces AC voltage, and you need a device to convert AC to DC. All right. Um, it's actually it's actually interesting though because I did teach you this some time ago.
Diode, sir. The diode.
Yeah,
Yes, sir.
but again, nobody remembered. Um, Anyway, but this is the device you may use, the diode. So they're looking for that. All right, so let's put diode here. Probably we need something else too, but I don't know. Them say it's them say additional. Oh, probably hold on a sec. It might be a transformer in there. Let's see something. Stationary coil. You're turning this. You probably would need a transformer here, would it? Let me see something. Rechargeable batteries, light emitting diode. I think this is vague because
They actually said one. I think they said one component also to see.
they say what additional component. They didn't say one.
No, I mean like it was one. Like it was one. It's referring to because it says component is. That's what it didn't say components are. That's what I was saying. Probably one in E.
Yeah, definitely. Diode here. All right. Well, all right. So let's confirm that then. All right. So, there you go. At a reasonable cranking rate, the unit generates 6.2 volts. Calculate the current if the resistance is they actually have 310 ohms here. So this is a calculating question. Oh, so I look like a one word them I look for here. One word here, so bam bam. And then no, this will have a 3 marks, which the total here is 5. So because I get 3 marks with this. So calculate the current. All right, so you have resistance here. 310 ohms. You have a resistance and you have your voltage. And they ask for current. What formula are you going to use here?
Resistance is a calculate the current.
Yeah.
I equal V over R.
Well, let's see if we can go back to basics here. All right. So
like V up at top and I over the left, R over the right.
All right. So yeah, resistance. Right. So resistance. So then you get 1 mark for writing that formula. All right, you have the 6.2 and then you have your 10. All right. So let's put in the numbers here then. So the voltage here is gonna be
6.2 volts.
Yeah, the resistance here is
310 ohms.
Yeah, definitely. And you're finding the current there. All right, so it's interesting though they actually did it's 310. It's supposed to be 0 0.2, 0 0.002. Something like that. You should get some 0.02 business here. You work it out. All right, and of course that's one way. Similar device. That's why I was on there.
Sir, it's 0.02.
0.02 is the answer. All right. All right, so 0.02 amps. I hope everybody see how work that out. All right. So the same thing as 6.2 volts divided by 310 ohms. And that would be 0.02 ampere.
Or they could write the formula like I equal V over R.
Well, yes, you could do that. Same thing. Yeah, you could do it that way as well. All right. This part about a similar device. So then, because this is where I had the concern here, a similar device that includes a transformer. So them know, as it was 19 here, was it the transformer they wanted? But it turns out that it would be the diode because, well, if its battery is gonna be DC, but then they've known that some of them have transformer in there. I was just about to question whether it's just the diode they wanted, but the transformer is another version of it. So all right. So anyway, yeah, so the marks about the same transformer business here. All right, we this is something that we're not really going to know we actually introduce a new concept here. But the transformer does have a formula here, which we will discuss that next class. All right, so in the meantime, we can just, well, we'll find some other questions here. All right, I'm gonna leave you with this one. And this will be the focus here for class. All right, for next class. In fact, I want this to be done. And this part for 6 marks. All right,
That's it, sir.
Right. You mean this?
Yes, sir.
This is question 6, man. So this need to do this. All right. Where is it? The class now. Actually, I can't find the oh, here it is. Okay, so this is interesting. Why is it physics class so far back? All right, so all right, so we have that there. All right, and this is yeah. So there it should be seeing it in the group. Yeah. All right, so maybe should be seeing that in the group. All right, so okay, that's question 6. Yeah. Okay, so I would say do try the question and discuss it. All right, guys. Don't expect me to go through it in class if nobody do it. If nobody do it, or too few people do it, I'll just forget the question ever existed and move on to something else. But I want you guys to try this question. What's that?
Should we send it to you on WhatsApp?
Yeah, man, sure. Can send it on WhatsApp. Let me say try the question. And then I give everybody an individual response. But you can discuss it in the group, ask any questions you have in the group. And then so we can, so that one person don't ask me the same question that other persons ask. You ask it in the group, then the question can answer one time. So, but I'll give everybody an individual response to the questions when I'm sending it by WhatsApp. All right. So that's it. I mean, I would say we're trying to get you guys to understand how to work these electrical questions. We're still not under the concepts that, well, we still need to look at some other type of electrical questions and to be even more ready. So, but this is like a little introduction to it. So try and understand this part. All right, I would say if most persons do it, in fact, if most persons do this, then I'll just go through it in class and then show you the answers that you should have or highlight those who gave me the correct answers. And then no, we take it from there. All right. But yeah, so this is just a question that's looking to see if you understand the basic stuff about circuits. And what you don't know, you have one of two choices. You can research it, or you can ask the question in the group, whichever way you get the information. So that's all up to you guys. But see, I'm leaving you with that. All right, guys. So that's it. Well, thanks for coming out tonight, guys. And to say, I hope you're going to take up your book and try this, and so that we can have some progress for next class. All right. Getting very near towards the exam, so you might want to take the work more seriously now. All right. So until when is it now? Until Thursday. I'll see you then.
Yes, sir.
All right.
Nice, sir.